Hello everyone, welcome back to our second webinar. This month we're talking about interoperability in action, data standards and marine applications. We have some really interesting presentations today from Allan and Mike, so I'm really looking forward to. I hope you are as well. For those that weren't here last time, my name is Roseanna and I'm the workstream lead for standards within the MEDIN core team. And part of my role is coordinating the delivery of training. We run regular training workshops online. And this webinar series is our newest offering to allow us to cover some topics in a bit more detail and showcase some of the examples of how MEDIN principles and tools are applied by some of the organisations in our network. We want to encourage discussion and curiosity, so if you have any questions, please send them in using the Q&A. You can also upvote other people's questions, so please do that if anyone's already asked a question that you really want to know the answer to. These webinars are also being recorded and will be uploaded to the MEDIN YouTube channel. So if you find it really interesting, you can share it around, or you can rewatch it if you want to revisit anything later. First of all, I wanted to give another brief introduction to MEDIN for anyone that wasn't here last time, but with a slightly different focus, so hopefully it's not too repetitive for anyone that was here last time. So again, MEDIN stands for the Marine Environmental Data and Information Network. Our tagline is measure once, use many times. The presentations today are about data standards and interoperability and management and utilization of data. So I thought it would be good to go into a bit more detail on MEDIN's data guidelines and the Discovery Metadata Standard. MEDIN is a long-term open partnership, and our aim is to make UK marine data findable, accessible, interoperable and reusable, or FAIR, by providing marine data guidelines, a metadata standard, tools for creating metadata, an online portal to act as a hub for access to UK marine data, and access to expertise from our specialist data archive centres. We're funded and governed by a consortium of 16 sponsors whose logos are along the bottom of the slide here, and we have over 60 partners who are UK organisations that adhere to MEDIN standards and promote good data management practices, making it easier to find, access and reuse UK marine data. We also have 7 accredited data archive centres specialising in different data types, and we've been working with UK organisations since 2008 to promote good data management practices. So marine data standards are important because marine data is expensive to collect and often irreplaceable. So it's really important that we collect all of the metadata required to be able to reuse those data and also make them findable so others can access and reuse them. And the easiest way to do that is to follow a guideline or a standard. So by collecting consistent metadata and saving them in standardized formats, we can ensure that they can be reused. For example, to the right of the slide, we have a map showing model probability of the presence of juvenile haddock. We also have overlaid the haddock nursery and spawning grounds. So you can imagine how being able to collate different data sets in one place like this and being able to use them together could be really useful to inform policies, support better decision making, and even be useful in scientific research where you might be able to draw on existing data to support and give context to new data that you've collected, or provide justification to go out and collect new data. Establishing robust marine data standards is essential for ensuring consistency, interoperability, and long-term usability of marine data sets. One of the key tools in supporting this is the MEDIN Discovery Metadata Standard, which provides a structured framework for describing marine data in a way that makes it easily discoverable and accessible. The MEDIN Discovery Metadata Standard is derived from the ISO 19115 through Inspire and Gemini, so it's fully compliant with these, but it's UK marine specific through the controlled vocabularies that we use. The standard requires the discovery metadata to be in a particular format called XML, or Extensible Markup Language. And since XML isn't particularly friendly for everyone to work with, we provide some tools to help people create their own discovery metadata. So we've got the online discovery metadata editor, which is suitable for generating metadata for a small number of data sets, and those can be exported directly into the MEDIN portal. We also have Metadata Maestro, which uses web services to access required vocabularies when an internet connection is available. Otherwise, it can operate in desktop standalone mode. So that makes it really good for working anytime you don't have a reliable internet connection. We also have a tool called the MEDIN schematron, which carries out validation. So it scans the structure of the XML, the requirement levels and other rules of the MEDIN standard, but doesn't QC the content of the record. The schematron is used by both of the tools. So anytime there's updates to the standard, we can make updates to the schematron, and then update the validation rules in both tools at once, rather than making bespoke changes for each tool. It also allows any organizations that need to make large numbers of records themselves, if it's easier for them to automate the creation of the records within their own systems rather than using one of MEDIN's tools, it allows them to validate their own records as well. So on the screen at the moment, that's an example of some XML and some of these schematron errors that have come up. Then because all of the discovery metadata records from all of the different organizations have the same format and contain the same information, we can display that on our centralized portal, so users can search for all the datasets all in one place. We currently have over 18,600 datasets from over 600 originating organizations. And also because the standard is compliant with national and international standards, these records can be further distributed onto other initiatives like data.gov, ICES, the International Council for the Exploration of the Seas, EMODnet, the European Marine Observation and Data Network, and ODIS, the Ocean Data Information System, to make these datasets even more widely discoverable. So while the Discovery Metadata Standard ensures that marine datasets are consistently described and easily discoverable, the MEDIN data guidelines provide practical advice on how to structure, format, and submit data in alignment with MEDIN requirements, ensuring quality and usability. Essentially, the guidelines are a reminder of what metadata need to be collected to ensure reusability of the data. They're derived by community users and the data archive centres and allow data to be easily ingested into the data archive centres. There are controlled vocabularies and recommended formats for the metadata to be provided in, which helps standardise the data and instill good practice amongst users. They're also really useful for contracting organisations because they provide a standard format to provide data in, so it's much easier to collate the data from different contractors and be able to ensure the data provided are good quality. The guidelines are tailored to different methods and data types and split into themes on the website to make them easy to find. The data model for the data guidelines needs to work across a variety of use cases, from a single sighting by a member of the public to a multidisciplinary research expedition. So we have different levels within the metadata, which can be bolted together in different ways as necessary. So there are a few different levels. We've got the general metadata, which provides information about the project and the survey, and those fields are common across all the guidelines. Then we have detailed metadata, which is the method information, that's specific to each guideline. And then there's the data, including station, event, and the data themselves. So station includes all of the same fields across the same all of the guidelines, because these are fixed stations and you might collect many different data types one fixed station. But the event metadata being the information about the times and locations and conditions at the time of data collection, and the data themselves are specific to each guideline. Although we are working on making the guidelines more modular and ensuring field names are consistent across guidelines so they can be blended a bit more easily. This is an example of how you could bolt together multiple guidelines, or in this case, one project, a couple of different surveys, collecting different data types during each survey. So we have sample events for each different sampling methodology, with fixed stations linked when applicable, as well as methods and the data linked from the specific guidelines for that data type. It's formatted a little bit like a relational database. So there's unique identifiers that link all of the levels together and link all of the information to each other. This is an example of some detailed metadata guidance from one of the guidelines. So for every field, there'll be a field title, whether it's mandatory, conditional, or optional, an unambiguous description. If there's a controlled vocabulary, that will be linked, or if there's a recommended format, that will also be explained. And then there's an example to help make sure everything is standardized as much as possible. We also provide forms that can be used to populate with the metadata and data, but we don't mandate any particular format. So the guidelines can be used just as a checklist to make sure all the necessary usage metadata are present. And as we heard from the Crown Estate last month, that's exactly how they use the guidelines. So again, that was just a very quick introduction to MEDIN and our Marine Discovery Metadata Standard and our guidelines. If you'd like to find out more or want some hands-on guidance on creating MEDIN compliant discovery metadata, searching the portal or using the guidelines, we run regular free online workshops. There's one coming up in October, another one in February. All of the details are on the website. We're also running an in-person workshop at MAST's ASM, the Marine Alliance for Science and Technology for Scotland's annual science meeting, and that's in November in Glasgow. It should be a lot of fun. So if you're up in Scotland or already attending MAST's, please consider signing up for that. We also have a YouTube channel with some quick how-to type videos if you just want some quick pointers. You can access all of our tools and resources from the MEDIN website, and you can follow us on social media for updates and sign up for our quarterly electronic marine newsletter, which is free and full of interesting articles from our partners and sponsors. And if your organisation isn't already a partner or sponsor, they could be. And it's worth considering. There's lots of benefits to joining the MEDIN network. And if you want to find out any more, you can email us. Thanks to all of our partners and sponsors. And I think we have time now for a few questions. If anything's come through in the Q&A yet.
Thanks, Roseanna. That was great. There's nothing in the Q&A just yet, but I do have a question for you. Are there any plans to further streamline or unify the data guidelines to make them easier to apply across different data types and collection methods?
Yes, there are. So while you can already bolt together multiple guidelines, if you need to, we're working on making the guidelines more modular. So rather than having completely different fields in certain levels of metadata, having fields and mandation levels that can be applied across multiple different use cases. That's what we're trying to work towards. And also we have a potential piece of development work to do with supplying the guidelines in an interoperable format like RDF or JSON, which would allow even easier interoperability between the guidelines and create some quite exciting possibilities to do with user interfaces and things like that.
Brilliant, thank you. I'll just give it a moment in case there are any more questions. I do have another one. And how does MEDIN ensure that metadata remains compliant as international standards evolve?
Yeah, so that's a good question. We are actively involved in several working groups to do with the national and international standards that our standard is derived from. So, for example, the Gemini working group, and that way we have warning when updates are being made that might affect our own standard, and also we can feed into the discussion, making sure that any changes that are made to the other standards can be merged into our standard and won't cause any issues with compatibility.
Thank you. There's a question from Ollie Williams in the chat. Would you have any advice for those trying to assess whether data across a whole relational database meets a given metadata standard?
Tricky question. Might have to have a little think about that and get back to you, Ollie.
That was a good one, Ollie. And we've got a hand up from Mike.
Yeah, just following on from the last question, I'm not sure it's an exact answer, but one of the easiest way to do it would be to export one of your metadata files from your database, and then use the MEDIN tools to verify that against the MEDIN standard. Obviously, you wouldn't be able to be categorical about every other metadata record that you have in there, but at least then you'll know whether the structures of your data tables or your metadata tables are correct or not. So that's kind of like the easiest, one of the simplest way to at least get some way towards ensuring that your entire database is compliant.
Thank you, Mike. Do we have time for one more, Roseanna?
Yeah, I think one more should be fine.
Okay, currently the XML format is used, but is there any consideration of supporting formats such as JSON in the future?
Not sure if it already might be in some cases. I think for the standard at the moment, XML is the format that we use, but we are looking into JSON for the guidelines. I'm not sure if my colleague who works on the Discovery Metadata Standard, might have a comment on this that he could put on that question.
Okay, and I think that's all for the moment. Thank you, Roseanna.
Thank you. So I'll stop sharing. And next up is Allan from Ordnance Survey, who's going to talk about data standards and interoperability from their perspective. So I'll just bring him up onto the screen.
Right. Hello, everyone. Good afternoon. Have you got my slides there, Roseanna?
Yeah, looks good. Thank you.
Good. I'd like to thank MEDIN for the opportunity to speak about standards and our approach here at Ordnance Survey. I did enjoy your presentation, Roseanna, because there was a lot of good standards content in that. And I do have an opinion as to whether we should XML or JSON, but maybe I'll keep that one to myself. Okay, so my name's Allan Jamieson. I am the data standards lead at Ordnance Survey, and the work that I do is in 3 levels. So I work internally to make sure our organisation and the organisations that we work with, we're working with the correct standards, and that we're looking to the future. I also chair a standards group within the BSI across the UK, and I also do some international work with both ISO and OGC. So from that point of view, we kind of cover all bases. Okay, so today what I'd like to talk about is on the agenda there. First of all, to give my view of what I think data interoperability is. And then to take an example, and the most appropriate example for me is the intertidal zone and the interoperability of data between them. I'd then like to tell you a bit about a project that Ordnance Survey has been supporting, which is the data integration with the land-sea interface. Have a chat about some of the interoperability gaps that have come out of that project and try and come to some sort of conclusions, if any conclusions can be derived. You'll not be surprised to hear that Ordnance Survey, we also recognise the Q-FAIR data principles. And the Q was added by the Geospatial Commission in the UK in a paper about, I think it was about 3 or 4 years ago, standing for quality. So there's a lot of standards involved in making our data more findable, and I think that they were well advocated by Roseanna in the last presentation. What I'm here to do is to focus on the I part and the interoperable part. And if we break interoperability down, I think there's 4 areas that you can focus on to make your data more interoperable. The first is the all-important data formats. But the caveat here is that you should be using open data formats, so formats that you can take part in standardizing. What I'm not thinking about here are things like Esri shapefiles and things like that. So both GeoJSON and GeoPackage there, they're vector files, and anyone can contribute to the development of the standards of those formats moving forward. And the key to that means that you'll be well away from any sort of vendor lock-in in technology, and both those formats are well distributed. The second are data models, and there are a couple of ISO formats that help you put data models together. And if you have a data model, and you want to exchange that data with someone else, then that's easily describable using those standards. And then if you extend that understanding of data to actually into the semantics as to how we describe data, how we build that understanding between two different worlds. So the classic example is a lighthouse. Ordnance Survey, we classify it as a building, but UKHO would probably classify it as a navigational aid. So the semantics is quite important, and there's an ISO standard, Inspire standards help us to define those semantics differences between data sets. And then the final one, as I probably won't touch on much, which is our common system architectures, essentially the IT systems that our data sits on. A lot of organizations are moving to the cloud, and whether you're using Azure or AWS or something like that, cloud native standards that allow ease of data between different clouds is an area of standardization that is gaining traction. Okay, the intertidal zone then, I probably don't need to tell this audience much about this, but it's sometimes known as the white ribbon. I've also heard it termed as the coastal ribbon. So there you go, there's a semantic issue straight away. It's obviously highly dynamic, and the second point there about it being difficult to measure is because if you're capturing data on land for Ordnance Survey, how far do you go out, and where does the marine capture start? You know, it's that sort of fuzzy boundary line. And the thing that makes that more difficult is that the organisations that look after land data, like ourselves at Ordnance Survey, or someone such as UKHO, then they're governed in different ways, different legal systems. So that's why we end up with both data gaps and what I would term a sort of data governance gap, because there's a governance gap in there that prevents interoperability of data sets. Yeah, so why does it matter? I think that's a very good question. Does it really matter? And the answer is yes. There's 4 use cases there on the screen. And my thinking at the moment is that these are becoming much more obvious, and we do need to find easier solutions to help support these use cases. And that's why data interoperability matters. There's lots of other reasons, but I think if you're trying to relate what we do back to government policy and ultimately populations that live on the coast, then those 4 things there are important. Okay, so the first next slide I'd like to talk about is a project that we have been supporting at the Open Geospatial Consortium. And the Open Geospatial Consortium is an international organisation that get involved in standards and also involved in innovation with geospatial data. Ordnance Survey have been a member for a number of years, and in the back end of last year, sort of last autumn, they put this project together, brought together 3 technology partners to work with land and sea data sets. The 3 are listed there on the screen in a brief description of what they were looking at. So CompuSalt were looking at fusing data sets together for navigation, and Pangea we're really looking at the discrete global grid system as a potential solution to interoperability of different datums in the intertidal area. And then T-Carter, we're looking at some satellite-derived bathymetry, again, to look at that, where the land data stops and the marine data capture starts. We had two areas of interest. Ordnance Survey provided some data for the Solent, as well as UKHO. And the link at the bottom there is to the project website. It's available now, and there are two other outputs which are just being finalised. The first is an engineering report, that provides all the detail of how the technology partners went about their work. And the second is a best practice report, which is just guidance on if you are faced with a project and you've got to bring land and sea data sets together, what's the best way to go about it. But we have been here before. These two screen grabs were quite dated, from 2001 and 2003. The Ordnance Survey project, ICZMAP, predates my time at Ordnance Survey. I wasn't at Ordnance Survey at that point. But around about that time, I was working for a different organisation, and I was capturing aerial photography and LiDAR for the English Coastal Management Programme. So my involvement in this particular programme goes back quite far. And the project from 2003, that ICZMAP, what came out of that was VORF. So the vertical offshore reference frame that we all know today came as a result of that project. So these things do work, and we do make incremental changes to how we bring our data sets together. Okay, so next two slides are actually on some of the data interoperability gaps that we've seen. The first one, temporal and spatial inconsistencies. Now, that is probably quite an easy thing for this audience to understand. But what that tells me is that there's lots and lots of data sets out there, and they're captured for bespoke reasons, and update cycles are different. So I don't think there's a shortage of data. This is what I'm trying to say. I think there's lots and lots of data out there. The vertical and horizontal reference frames, again, probably obvious to this group. Ordnance Survey, we work to mean sea level, whereas UKHO, they work to LAT, lowest astronomical tide. So there is an obvious gap there. Yeah, and I think if you've done any work in this field, then that should be obvious. And that's the issue that Panagea are trying to solve with the DGGS. And the other thing that came about was really sort of a lot of data fragmentation. There is a lot of data out there, but it's held in lots of different places. And MEDIN does a great job in being able to allow data users to find data from other organisations. Finds one part, but when you've got access to that data, how interoperable is it? And what my thinking on this really is the starting point really should be trying to align the use cases together. So making a connection between government policy and the use case and the data that would be required to serve that use case. So an example could be that the government has a policy of climate change adaptation, okay? Not just on the coast, but across the whole country. And the use case could be coastal erosion management, for example. And then when you think about coastal erosion management, what data do we need to be able to serve that, right? So you would specify things like, obviously, the areas, the resolution, you would specify the coordinate system, schema, etc. Then you start to have a data standard that everybody agrees, and it would need to be everybody. There would need to be a lot of consultation. But that's the data set to serve that particular use case. But the good thing about the ISO 19131 data product specification is that it also covers off what I mentioned earlier on in terms of data gaps, data governance gaps, I should say. So there is provision in that standard to record use cases, for example, why collect this data in the first place. There is also provision to cover other elements such as the data quality measures, that you're going to measure the data quality of the data and the values for acceptance, and also maintenance. So there's provision in there to say that this data set will be maintained every year, every 18 months, or whatever the case may be. So you've got both the data itself, the gaps in the data itself, and the data governance gaps covered by that one standard. And then once you've established that standard, then that's the time to start and focus on the formats, the models, the semantics, and the architecture that I mentioned earlier on. Okay, then there was another few data interoperability gaps that we saw. One was semantic interoperability, so the lighthouse issue, and a lot more than just lighthouses. Obviously, there's how Ordnance Survey described rock formations in different ways, and sandbanks and things like that. So you need to drill down and start with a controlled vocabulary and build a taxonomy from that, and maybe even a full ontology for the intertidal area. And that would help a lot, to particularly for if you use the data for AI applications. Metadata and quality control, there are a lot of standards out there on metadata. And there is quite a lot of alignment at the moment, because the metadata that's used in the S100 set of standards was actually modelled on the ISO 195. So there shouldn't be too much of a shift to bring those two together. The one that a data gap is a physical gap itself. There's not any standards that you can use if there is a physical gap. But I do think that certainly during my career, things like satellite-derived bathymetry, bathymetric LiDAR, they're all improving, and hopefully those actual physical gaps, they are fewer and far between. So just go on to my last slide then, which is just some conclusions. I think as a community, we get together and make that connection between policy to use case to data. Can make use of a data product specification to pin down all of these things, and then once that's done, we can really focus on the 4 elements of interoperability and the formats, models, the semantics, and the architecture. And that is really quite a relatively simple message, but that's our view here at Ordnance Survey. So thank you very much for your time.
Thank you, Mike. Not Mike, Alan. Thank you. That was a really interesting presentation. I will hand over to Charlotte in case there's any questions so far.
Thank you, Alan. That was brilliant. Yes, there are a couple of questions. So the first one is, do Ordnance Survey have a vocabulary that defines and describes raw data versus data products and the levels within each category? We struggle for consistency on this, even within the marine data community.
I'll probably need to check up the detail on that. If it's not something we've already got, then it's something that we're definitely looking at. The one thing out of those 4 interoperability elements, I should say, that I think is the one that's probably been neglected a bit and needs a lot of work, is the semantics, is those control vocabularies into a taxonomy. And the reason I say that is that AI will read that data. So if you want to expose your data in the future, which we probably all will, to an AI for AI to run queries on your data, then you need to pin down the description of your data as far as possible, and that does mean better semantic descriptions. That might not have answered your question. hopefully.
Yeah, it's all right. Thank you. Another question is, you've mentioned 4 elements of interoperability. Is there one
Yeah.
of them that you would prioritize over the others?
Yeah, it's the semantics. Yeah, definitely. I think we're good at find. I think MEDIN have shown that. Ourselves at Ordnance Survey, we've got catalogues as well to our data, and our data is exposed to data.gov.uk, etc. So the cataloguing thing's coming. I think it's, but it's the semantics really that the one thing for me that needs to be worked on.
Great, thank you. That's really good to know. And then I've got one more question. What do you think is the best way to bridge all of those data governance gaps that you mentioned earlier? Because there were quite a few.
What's the best way? It's an old-fashioned answer, and that is getting together and collaborating. Okay, I think Ordnance Survey, like every other organisation, we are 100% comfortable with the fact that the data set to solve a particular use case can be held in lots of different places. 100% comfortable with that. We share data with our partners in a federal environment. Okay, so for example, the British Geological Survey, they've got some of their data sets available via our data hub. Okay, and we're starting to talk to partners about bringing data sets together to solve particular use cases. So that's why I say that the policy use case data comes first, and then the data follows in behind. And there's lots and lots of ways in which we can collaborate. So as a standards lead, and I chair a standards committee, we talk standards all the time. There's no reason why we can't talk data and use cases with the same organisations. And I do that at the British level and at international level. Yeah, good old-fashioned getting around a table. This is the target. This is what we're going. Let's collaborate. But we do need that target. We do need that use case.
Brilliant, thank you. Do we have time for one more, Roseanna?
Yeah, I think we can squeeze another one in.
Okay, thank you. So I think our last question is, MEDIN advocate the use of the NERC vocabulary service for controlled vocabularies and semantics.
Yeah.
Do you know if Ordnance Survey are already keyed into that?
I think we are. Ordnance Survey is quite a big organisation. Yeah, I think we are, because we certainly take tideline data and things and tide information. So I would expect us to be part of that. Yeah.
Brilliant, thank you so much.
Great, thank you. So now we will move on to Mike, who is going to talk about data use in ports.
You can't hear me because I'm muted. Thank you, Roseanna. Hopefully you can hear me now and you can see my screen.
Yeah, looks good.
Lovely. Okay, well, good afternoon, everybody, and thank you, Allan, for a fascinating talk there. I was involved in ICZMap all those years ago, and you mentioned VORF, obviously very important output from ICZMap, but the other important output, which kind of supports what you were saying and would wholeheartedly agree with these semantics interoperability, is that Ordnance Survey took their mean high water spring line and made it contiguous around the whole coastline, and then that allowed us to actually have a coterminous line that we could combine land and sea data sets. There were other issues, of course, as you mentioned, but that was a major step forward way back then. I can't believe it's over 20 years ago. Anyway, another segue really into your talk is I'm going to be talking a little bit about where S100. So those of you who were wondering what S100 was all about, then listen on. So I'm going to talk about the importance or the application of interoperability and data standards in ports, and this is something that's I'll just change the slides. Okay. Right, sorry, is there an easy way of moving the slides on without having to go switch back to PowerPoint?
Try the arrows on your keyboard.
I've just tried that.
Forward arrow.
No, because I'm in the wrong application. Okay, I'm going to have to go back to PowerPoint and talk and not see what's going on. So if you can let me know if there's anything that goes on which is important. And
if you prefer, I can share your slides and just move them on for you. If
yeah,
that's easier.
okay.
I'm not
Yeah,
sure.
yeah, I think it probably is. Thank you. Sorry about this, folks. Okay, terrific. Right, so what I wanted to say is talk about give a little bit of background in terms of the data sets that that a port authority might want. Well, a port is a multifaceted business. It's involved in a whole range of different activities. We're just focusing on the conservancy aspect of ports. Then this is laid down in the Port Safety Code, which is a DTI document that all ports have to adhere to. And there's a number of sort of regulatory and other compliance requirements that requires a port to undertake certain activities, and some of those activities are listed there on the screen. Now, as you can imagine, that for each of those activities there are data inputs and data outputs, and these data sets aren't data sets that are generated by the port alone. They are generated from external sources, and also the port shares its data with an awful lot of other numbers of external stakeholders. Okay, next slide. Okay, so the sort of questions that a port will ask itself when thinking about the data and information that it's hold is, well, what do we currently in a situation where they want to try and improve their efficiency, their data management efficiency, or improve the data governance of their data assets under the Port Marine Safety Code, for example. And so where does the data currently exist? And in a lot of cases, especially going back a few years, it exists in paper format, in Excel format, etc. They will ask themselves who's responsible for each data set or data asset. This could, like I said, could be an internal department, could be an internal individual, or more likely as an external body that's involved in that as well. And how do we know, how are we using that data? What processes, what operating procedures within the port does that data set support? How do we keep it up to date? When do we need to keep it up to date? When was it last updated? How is that data quality controlled? How do we know? In other words, how do we know that that data set is fit for purpose, and how do we prove that that data is fit for purpose? Say, for example, for audit or compliance purposes. Next slide. Okay, and like a lot of organizations trying to improve the way that they govern data, the information technology has evolved over the last 20 to 30 years, and that's resulted in a lot of departments, a lot of organizations keeping data in what's now termed as sort of data silos or data flow stovepipes. So the accounts department will have their own data sets, usually accessible through some sort of user interface for accounting package, whatever it might be. Operations, logistics, again the same, their data sets. Estate management, and the conservancy aspects will have their own data sets. Next slide. And the result of this, as well known, is inconsistency, replication, inefficiency, and confusion as to which data sets should be using, therefore making data sharing extremely difficult and time consuming. And various studies over the years have found out that a lot of the time spent, users spend with data. It's actually finding that data and having then to reformat that data. Next slide. So, but if you sort of step back and ask users what they want, well, they want their data easily accessible and all in one place. This is known as establishing a common operating picture, or in military terms, establishing a recognized environment. And they want data that the users want data that is relevant, described, understood, and up to date. It's just an image there of a study I was involved in post Deepwater Horizon, which went as far as identifying the various data layers, but didn't really go into what are the sources of each of those data sets and how do we then combine those data sets? Are those data sets, once we get them into the common operating picture, are they interoperable? And in most cases, no, they weren't interoperable. And a lot of work, a lot of pre-proprietary work had to be undertaken to make those data sets fit for a particular purpose. Next slide. So, in other words, each data layer requires some sort of data governance. They need to be part of a data management system where we are improving those data sets. Next slide. So how do we go about doing that? Well, we need to make data a priority. We need to make it a business priority. We need to make data, we need to put data management or data governance alongside our other management systems and our other management priorities, such as for quality management, environmental management, health and safety, environment. And our data governance ideally should be implemented as part of that business management framework. And the course that you mentioned, that Roseanna mentioned earlier, the MEDIN course, we go into this in a lot more detail. So if this sort of is of interest to you, then do find out more about that course and ideally sign up for it. Okay, next slide. Okay, so what are we trying to achieve? Well, once we've identified our data as being an important asset within the organization, like those other data, other management standards, we need to implement some sort of policy and strategy. We need to identify our data managers and our data stewards. These are the go-to people for a particular data set. We want our data architects, we want our IT architecture to support our data architecture, not the other way around. And often IT people will present an IT architecture and say, there you go, data guys, get on with it. This is what we're providing you. So, well, it doesn't quite fit what we want. So it's a bit of the sort of the tail wagging the dog, if you like. The head of the dog should really be the data scientists and the processes that those data scientists are supporting. And we ideally need an IT architecture that will support what we're trying to achieve with that data. So there are key data principles that we need to try and adopt. But of course, within any organization, trying to change the way things working is often quite difficult, and therefore the whole issue becomes one of change management. Next slide. So what we've got effectively, we want to put data at the center. So we identified our processes, we identify our common data sets, and we identify those data sets that support multiple departments and multiple processes. And this has the general term data known as data centricity. Next slide. Okay, so just stepping back towards the port, there. So the port has hundreds of, if not thousands, of different data sets that it's having to deal with on a daily basis, both from logistics, security, all of the base mapping, both land mapping and sea mapping. I'm glad Allan mentioned the port as being a particular case study for land-sea interoperability. So what we're trying to achieve is basically to create a port or maritime information infrastructure. This doesn't mean that we're going to have all of the data that the port will use on a daily basis in one huge big database. It doesn't. It means that those distributed databases that are managed through different by different organizations using different applications have interfaces whereby those interfaces allow that data to be shared with others and within other applications. And there's no one single vendor, software vendor, that would be able to provide all of the different applications that a port supports. Therefore, the key is to ensure that those softwares and those software vendors provide the common standards to allow that data to be shared within and out with of the organization. And Allan mentioned the ports becoming smart. Well, what does that actually mean? Well, they have to create a foundation which allows data to be shared, and therefore that will allow them to reach this sort of smart status, if you like. So get the building blocks right to become smart, then you will become smart. Leap into trying to become smart by implementing new technologies without thinking about the data, then you will fail on that journey. Next slide. And this is just one practical example of environmental monitoring, where there are lots of different players active in this, from weather forecast providers such as the Met Office. We've got AIS, which is a marine equivalent for air traffic control, and then we've got different techniques. So different software such as portable pilots units, vessel traffic services. All of these systems have to share data in one way or another, and there's no immediate standard that can be adopted. Now, Ocean Wise has been working with Trelleborg, who provides portable pilot unit softwares, and we've started on an IMO specification known as Circular 289 to share data. Now, it's not ideal, and the future really is S100, which Allan mentioned. Next slide, which I think is hopefully my next slide. Yeah, I'm just highlighting where the interfaces are. Yeah, there we go. So IHO S100 is developed by the International Hydrographic Organization, but it involves the International Maritime Organization, the Association of Lighthouse Authorities, the World Meteorological Organization, and it is based on ISO 19100, which Allan mentioned. Therefore, if all of the various standards within the ISO 19100 are complied with, which S100 does, then all of the different data sets in this S100 landscape, if you like, should be interoperable. But not only that, it means that those data sets will also be interoperable with other geographic domains, such as the land mapping, for example. So each of these specifications that you see there are all based on S100, and therefore are also based on ISO 19100. There's still a long way to go, but I think there are 4 or 5 live specifications now, including the specification for electronic navigation charts, a new S100 based specification for electronic charts, S101. Next slide. Okay, and this is just an example of where this is one particular application. This is the Port of Dover, and not only can you see there's a base map there, but there's also the tide and weather observations. So I think if you do a couple of clicks, please, Roseanna. Yeah. So what the Port of Dover have done is they develop an application, and not only can you see the tide and weather data, but you can also see data on ferry movements, on safety notices, etc., etc. And this means these data sets have to adhere to the same standards, and therefore have to be interoperable to allow that data to be brought into this single interface. Next slide. And this is the same. This is very similar here. If you just do a couple of clicks. So here, what we're doing is we're using So this is for this is an asset management port asset management system, and what we're doing is we've taken the Ordnance Survey master map data, and we're using the topographic identifiers within master map to link business data to each of those geographic locations. And you've probably heard the phrase "everything happens somewhere," where you can use that somewhere to link disparate data sets. And once you've done that, you can then use that data not only for asset management, facility management, but you can also use it downstream to, for example, create mapping for portable pilot units, for VTS, and also to feed into business intelligence or artificial intelligence applications as well. Next slide. So all of these things require an understanding of addressing data management and quality issues. And one of the dangers that I think a lot of organizations fall into, and the same now with artificial intelligence, any black box is only as good as the data that you feed into it. Rubbish in, rubbish out. So we need to think about the data, we need to think about data governance, and of course, therefore, we need to think about the data standards, which hopefully will then lead us to have interoperable data sets where we can achieve what we want to achieve. I think that's the end. Thank you.
Great, thank you, Mike. Hand over to Charlotte again, if there's any questions.
Thank you. Thanks, Mike. That was brilliant. We have a couple of questions. Are you aware of any tie together between the S100 initiative and Darwin Core GBIF? Would be great to be able to integrate between the biodiversity and oceanographic elements.
Did you say Dublin Core or
Darwin Core?
Darwin Core. I feel as though I should know this because it's come up in terms of the MEDIN data guidelines. I think I need to have a look at that to find out a little bit more about Darwin Core. If it's the same as Dublin Core, it'd be a metadata standard, in which case I would say, or a metadata schema, in which case I'd say we'll move towards MEDIN, because we know that MEDIN is ISO 19100 compliant. So I'm going to look into it that a little bit more detail.
No problem. Thank you. Have you noticed an attitude shift towards data sharing and interoperability within the port authorities since OceanWise has been working with them?
Yeah, absolutely. But interesting, it hasn't primarily been driven by the conservancy side of a port's responsibilities. It's normally on the estates management side, and on the logistics side. I think the next big step is to link the logistics and the conservancy with what's going on within the IMO with e-navigation and maritime services. We've been involved in a couple of projects with Peel Ports and with the UK Hydrographic Office to broadcast tide and weather data as part of a maritime service to ships at sea, with the ultimate aim of having just-in-time port entry. So a traditional way a port would operate would be a ship would anchor off until the pilot was ready to meet them and they could bring them to the berth. So the idea really is for the ship to slow down and reach the port at exactly the point when the pilot comes out to meet. So you don't have to anchor, therefore saving fuel, saving pollution in the local area as well. So it's linking data sets for real world improvements, really. So it's gradually coming. It's been a long slow process, but I think the need is there much more than it has been before, and it's the need which will ultimately drive this change.
That's great, thank you. I'm not seeing any more questions. Hand back over to you, Roseanna.
Thank you. So I'll just share my screen again quickly. So the one last thing before we close the session is it would be really wonderful if everyone could fill out the feedback survey. It's anonymous, and your feedback helps us to improve future webinars and events and gives us justification to run similar things in future if you've really enjoyed it. I'll send around the link afterwards as well, so don't worry if you don't manage to get to it right now. So the last thing is just to say a massive thank you to Allan and Mike for presenting today, and to Charlotte for monitoring the Q&A. And thank you to everyone for attending and asking questions. I hope you've enjoyed the session and hope to see you at future webinars. Thank you very much.
Thank you very much.